Oke, selamat malam. Berjumpa lagi dengan saya Ahmad Farurosi di Lakoni Media ya. Kali ini saya ingin menunjukkan pengalaman saya mengikuti konferensi internasional, lebih tepatnya di ICWT 2021 yang diadakan tanggal 19 sampai 20 Agustus 2021. Dalam kesempatan kali ini saya agak sedikit ragu dalam artian karena konferensi internasional ini semua full pakai bahasa Inggris dan saya ragu terhadap kemampuan yang saya miliki, khususnya di bagian speaking, terus bagian mendengarkan orang ngomong bahasa Inggris itu kemampuan saya agak lemah ya. Tapi di sini saya memiliki tekad, kalaupun nanti di proses konferensinya berjalan kemudian saya ada kesalahan atau apa, itu akan saya jadikan bekal pengalaman buat memperbaiki ke depannya dengan tekad seperti itu. Oke, nanti coba saya ingin menunjukkan video ketika sedang konferensi internasional di ICWT 2021. Kalau ada kata-kata yang salah, teman-teman bisa sampaikan di komen. Oke, selamat menyaksikan.
Assalamualaikum warahmatullahi wabarakatuh. Greeting ladies and gentlemen. First, I would like to thank you to the ICWT 2021 organizing committee for the chance give to us. The title of our paper is ball identification and localization using regression for wheeled robot soccer. This presentation consists of 4 sections, namely introduction, research and method, result and discussion, and next conclusion, and then finally thank you. Our research is about robot soccer, which is a smart robot that is expected to have the ability to play soccer just like a human. Consequently, a soccer robot must have the ability to identify and find the ball so that the robot can move toward the ball and kick it correctly. There are 2 types of robot soccer. It is a humanoid soccer robot and wheeled soccer robot. Regarding previous research, first in 2016, Mr. Nugraha and partner has conducted a research to image processing with the template matching method. Next, in 2017, Mr. Utama and partner has success on detecting ball based on color and pattern. Then, in 2018, Mrs. Risma and partner has been able to control robot movement with a simple image processing method. And then our research was conducted in 2020, where the focus of our research in the analysis of the regression system in determining the distance and angle of the ball to the camera. The object of our research is a wheeled soccer robot that has a camera installed as an input device. and a Raspberry for the image processing function as seen in the left figure. The aim of our research is to be build a system so that the robot will be able to identify and locate the ball. The block diagram of the system can be seen of a right figure. Here we use a 5-volt DC as power supply, the camera module as input. The process continue on Raspberry using Python programming, which has the OpenCV library installed in it, which is easy after processing and calculating the distance and angle to be displayed on the monitor. And the ball that is used in this research is a red plastic ball with diameter 6 cm. There are two main processes. First is ball identifying, then the second is determining the position of the distance and the actual angle of the ball. As for the data collection room, we used a room with a size of 3 times 4.5 meters squared, a file size of 2 times 2.3 meters squared, with a lighting lux of 20x to 45 lux. Here are a step of ball identifying. After the camera is turned on, it will read the current frame, resize the frame, then a Gaussian blur filter is performed. Next, the frame will be converted to XSV space to make it easier to recognize the ball. Then the thresholding frame is carried out, and then judgment process is carried out whether the color of the ball is detected or not. If not, the process will be returned to original frame. And then if the color of the ball is correct, then it will continue to the object masking, filter erosion, filter dilation, and then find contour and determine the masking center point, and then finish. After the process flow in image processing is determined to determine the coordinate of the ball to the frame, the next step is the flowchart regression analysis in determining the actual distance and angle. First, we take data as many as 636 points. From this data, we then make a scatter plot. The result of the scatter plot model are then compared to the scatter plot, which is similar to scatter regression plot model, followed by determination of a similar regression model, then calculation the formula and calculation error from each regression until the regression model is selected with the smallest error value. Furthermore, the regression model formula is used to calculate an actual distance and angle through the conversion from Cartesian coordinate to polar coordinate. Continuing on the result and discussion, here the image of the conversion result from RGB space into XSV space, followed by determining the parameter value for whose saturation and value. The value obtained are X 175 to 179. And then S value is 140 to 255, and V value 20 to 255 for red ball image alone. While for the red ball parameter line up with other color, green and yellow, the X value is obtained 0 to 10. So it can be concluded that X parameter for the red ball is 175 to 179 or 0 to 10. In figure T is result shown by the monitor after image processing, thresholding process, dilation, erosion, and finally ball segmentation. From a file measuring 2 times 2.3 meters squared divided into square measuring 5.5 centimeter to produce 1,926 squares. 1,013 are visible to the camera and 913 are invisible. Furthermore, 636 square were taken representing the entire are visible to the camera for regression analysis. And then from the data that has been taken, generate on the left is a scatter plot for ordinate, and on the right is the scatter plot for axis. The resulting scatter plot has similar with quadratic regression and exponential regression for ordinate, while for axis has similar with cubic regression. After calculation, the formula W equals 221.x097 minus 2.0611x plus 0.0045 x squared for quadratic regression. And then ln y equals to 1.362 plus 0.0089 x for exponential regression. And next, y equals to minus 0.49 plus 0.207x plus 3.521 times 10 to the power of minus 6 x squared plus 5.992 times 10 to the power of minus 7 x cubic for cubic regression formula. Further related to the conclusion that we can summarize here, the first, in identifying ball, the method we use is color filtering in the XSV space. Second, in the result of the regression analysis for determining the position of the ball, quadratic regression is better than exponential regression. And for the axis, using cubic regression analysis. The third, the process of change from Cartesian coordinate to polar coordinate So that a calculation of the actual distance and angle of the ball can be obtained from the camera. Next, to calculating the error, we use an error calculation with MIA and MSA, resulting in 14.43 MIA and 248.07 MSA. And henceforth, the value of the regression analysis function that we project is ready to be implemented as input for the soccer robot motor movement. Finally, we say thank you and see you guys. Wassalamualaikum warahmatullahi wabarakatuh.